This is a video about a control system with the error signal amplified by 10. This results in basic tracking accuracy of the input signal versus the output signal. In this case, the input signal is 0, is plus and minus 12 volts. As you can see, and the signal saturates to basically VCC voltage. That's 5, 10, 12 volts. The range is 24 volts. The actual drive signal, therefore, is plus 6 and minus 6, as you can see. So let's look at the circuit. Our circuit is overall the input, which is step input of plus or minus 6 volts, and the resultant output, which is the same as the input after a oscillating response. And of course there is a voltmeter on the input versus the output. Here's the actual voltage commanded. The output becomes about 6.5, plus 6.5 to minus 6.5, with some oscillations necessary. Now let's look at the 5 volt, or rather I should say a 5 volt meter. Once the input equals the output becomes 0 volts, or the voltage between the input and output equals 0 volts, as you can see. So that's a good control system. And that's a tracking control system. And again, there is the voltmeter, input to output. What we're looking at is this error signal times 10. The error signal is there, and there is the signal times 10. There is the motor having a typical resistance input and resistance in the motor itself. And of course then the feedback back to the input. The input is plus or minus 6 volts, as I previously stated. Using a RC filter here, you enable this entire circuit to oscillate, which is typical of control systems. The error signal is simply taken here as the input versus the output, followed by a times 10 amplification, and then around the loop. The output has power, and the input signal could be virtually microjoules or less. It's all a matter of design. Here's a circuit which of course is hard to describe, but it consists of 3 large capacitors and the required resistors. The circuit has a time constant of about 5 seconds, and that drives the circuit. The output 6 volts is buffered by an op amp at that point, and the rest is a 3-stage op amp simulation of a control system. I hope you enjoyed this.